Hi Jacob, thanks for your question. To begin to solve this, what I'm going to do is I'm going to solve for x in equation 1, and I'm going to input what I find in equation 2. So if we solve for x up here, we get that x is equal to y squared, minus 7. There we go. Putting that in instead of x in equation 2, I'm going to get y squared minus 7 times y is equal to 6. I'm going to go ahead and distribute this y, bring the 6 over to the left-hand side and set it equal to 0 since we're solving it. So this is y cubed minus 7y. Let's bring the 6 over so it becomes minus 6 is equal to 0. To solve a cubic, well, there are many ways, but the least complicated way, in my opinion, is to use what's called the rational roots theorem. It sounds fancy, but it's really very easy. What we're going to do is we are going to find all factors of the constant term, so the non-y term, and all factors of the leading coefficient. That is the number in front of the cube term. So the constant in this case would be negative 6, and the leading coefficient, we'll just call it the LC, is 1. All factors of negative 6 are, and we're going to do all positive and negative factors. So if we factored 6, we could factor it into plus or minus 1 times plus or minus 6, or plus or minus 2 times plus or minus 3. All factors of the leading coefficient. Very easy, just plus or minus 1. Your possible roots for this equation up here are all factors of the constant over all factors of the leading coefficient. So my possible roots are plus or minus 1 over 1, plus or minus 2 over 1, plus or minus 6 over 1, plus or minus 3 over 1, which simplifies things for us greatly. Now we're just going to start guessing. I'm going to go ahead and start inputting these possible factors into this equation and hope that I do indeed get 0. So if we just input positive 1, we'll get 1 cubed minus 7 times 1 minus 6. That does not equal 0. It actually equals negative 12. So that's not going to work. Let's try negative 1. If we input negative 1, we will get negative 1 cubed minus 7 times negative 1 minus 6. Oops, there we go. And if we do some brief calculations there, we'll see that that does indeed come out to 0. So negative 1 is one of my factors of this equation. What I'm going to do is go ahead and divide out negative 1. You may have seen this before or you may have not. I'm not sure where you are. If you don't know what I'm doing down here, go ahead and keep inputting your possible roots into your equation up here, and whatever gives you 0 on the other side is a root. I'm going to divide out negative 1 using synthetic division. So I'm going to input this as 1y to the thirds plus 0 y squareds, I need that placeholder, minus 7y's minus 6's. I'm going to drop down this term, multiply these two terms, and put the product up here. Negative 1 times 1 is negative 1. That goes up here. I'm going to add down So I get negative 1 down here. Negative 1 times negative 1 is 1. Product goes up here. I'm going to add down. Negative 7 plus 1 is negative 6. And negative 1 times 6 is 6. Add down. And I get 0. And I should, because my remainder should be 0. So my factors of this equation so far are, oh, that's supposed to be a y, excuse me. Okay, y minus 1, or y plus 1, and I'm just going to reduce my original power of y by 1, so that I get 1y squared minus 1y minus 6. This is now reduced to a quadratic, which we can factor by traditional methods. I'm going to use the star method. Nice little star I got going there. Okay, we are looking for something that multiplies to negative 6 times 1, or just negative 6, and adds to negative 1. I know that 2 and 3 are factors of negative 6, and that if I add negative 3 plus 2 together, I get negative 1. So my factors of this equation are y plus 1, y minus 3, and y plus 2. So my possible values for y are negative 2, negative 1, and 3. I'm going to take these values for y. I'm going to insert them in whatever equation's easier to deal with, and I'm going to solve for x. So I think the easier equation personally is equation 2, x times y equals 6. So let's use that one. So we have x times negative 2 equals 6, which means that y in this case, x in this case would be 6 divided by negative 2, or negative 3. X times negative 1 equals 6. Let's divide both sides by negative 1 to get x equals negative 6. And x times 3 equals 6. Divide both sides by 3 to get x equals 2. So your solutions for this equation should be expressed in the form of points on the xy plane. And they are, let's see, when I plugged in negative 2 for y, I got x equals negative 3. So negative 3, negative 2. When I plugged in negative 1 for y, I got x equals negative 6. When I plugged in 3 for y, it's supposed to be 3, I got x equals 2. So these are your final answers for this equation. I just have to mention that we only plugged our possible solutions into equation 2. You do actually need to plug your solutions back into both equations to see that they work. So I skipped plugging the solutions back into equation 1 just to check, because I knew that they were going to work already. But you do need to do that in most cases. So these are your final answers. Thanks again for your question, Jacob, and I look forward to answering more of your questions using Snap Math in the future.